Hey guys, so in this video I'm going over Unit 2's quick review that I posted underneath the Unit 2 tab on our site. So for this one I am going to go over number 2 and number 4, simplifying radicals, and then I'll ask you to pause the video as you attempt number 1 and number 3. So for number 2, we are having it to simplify each little part. So first, I want to have a 2 radical sign. What is the understood number there as the index? A 2. Then we have our negative 180. So I want to separate out this negative 180. So first thing I want to take out is a 1. So negative 1 times 180 gives me 180. Now our negative 1 is prime, so we circle it. Now our 180, I want to separate what times what gives us 180. It is 18 and 10. Yes, you can come up with different numbers. It will still give you the same prime numbers at the end. So 18, we've got 2 times 9 gives you 18. 2 is prime, so you circle it. 9 is not, so you're going to keep going. 3 times 3 gives you 9. Then we have to come back to 10, because 10 is not prime. We have 2 times 5. 2 and 5 are prime. So through this whole thing, we have the square root of negative 180 turns into negative 1 times 2 times 2 times 3 times 3 times 5. Remembering that our index was 2. So that index is telling us how many of the same thing we can group together and move out of the radical, or out from under the radical. So the saying is 2 of the same get married, move out of the house, and become 1. So we have 2 2's. That means that 2 is going to come out as just 1 2. Our 2 3's are going to get married, move out of the house, and become 1 3. There is multiplication on the inside, so there is also multiplication on the outside. Now this negative 1, no, it doesn't have a pair or another negative 1 to pair with, but it is going to come out as an I, because the square root of negative 1 equals I, always. So we're also going to have a negative, or multiplication of I on the outside. And this lonely 5 is left on the inside. So this means that just the square root of negative 180 creates 6i times the square root of 5. Well, if you go back to the original problem, we have a 2 outside. And there's multiplication in between the 2 and the square root of negative 128. So we have 2 times, well, instead of writing the square root of negative 180, we're going to put the 6i times the square root of 5. And then simplify. So 2 times 6 gives me 12. I doesn't change, and the 5 doesn't change. Then we have plus or minus because most of this came out from underneath the radical. So that is our answer for number 2. Now, what if our index wasn't 2, or understood 2, like number 4? In this case, we have an index of 3. So that means when we expand our b to the 4th, which is the same thing as b times b times b times b, we're looking for a group of the same thing that is 3 different things that are the same. Well, we have 1, 2, 3 b's that are the same that we can group together and move out. So we have plus or minus b, and then we have a lonely b left underneath the radical. And there is a 3 still as the index, And that would be our answer for number 4. If you will, pause the video and attempt number 1 and number 3. So for number 1, you should have gotten plus or minus 5 times the square root of 2. For number 3, you should have gotten plus or minus x. Also know that if there was nothing left underneath the radical disappears. Alright. So 5 and 6, you are going in between radical and exponent or exponential form. So I'm going to start with number 6 because it's the hardest. And number 5, you're actually going to go backwards from what I'm doing in 6. So let's look at it. For number 6, you're starting with exponent. And you want to go to radical. So that means you have to have a radical in the radical form. And we want to get rid of this exponent. Well, before we get rid of the exponent, we've got to deal with this negative exponent because that's not possible. We can't handle it. We can't do anything with it until we get rid of it. So we're going to take everything but the negative and put it in the denominator. And then we're going to put on 1 on top, just as a placeholder, because we can't just leave the numerator blank. And that gets rid of our negative. Then we're going to go to the next step. We're going to have the 1 as our placeholder in the numerator still. We're going to have a radical sign. We're going to take the base of the exponent and put it on the inside of the radical. We're going to raise the base to the numerator, which is 2. And then we're going to throw the denominator to the index. So that is our radical form. So if you will, pause the video and attempt number 5. Number 5 is the cube root of 3x to the 5th. And you're looking up for your exponent form. Pause the video, please, and try it. So for number 5, you should have gotten 3x to the 5 over 3 power. Number 7. Number 7, you're having to solve for x. So kind of like that negative exponent, or the negative exponent, we can't handle solving something with the square root. So we've got to get rid of the square root. We can handle squares. So to get rid of a square root, let's say it was 2, we have to take the square of it. That gets rid of it. So it just becomes x equals 4. So that's a separate example. So in this case, to get rid of the square root, we're going to square it. Square it on both sides, because what we do on one side, we have to do to the other. So this is going to give us x minus 6 times x minus 6 equals 18 minus 3x. And then we're going to have to full it out. X times negative 6, 6 times x, negative 6 times negative 6. And we get x squared minus 6x minus 6x plus 36 equals 18 minus 3x. Then we can simplify our negative 6x's are like terms. So we get x squared minus 12x plus 36 equals 18 minus 3x. Then we are going to get one side equal to 0. Now we cannot, because we have an x squared and an x to the first, we are not going to be able to solve it by taking the square root and get rid of the square. We're going to end up in the same situation we were to begin with, where we had a square root and a square situation. So let's get one side equal to 0 and factor. So we are moving into the next step, which is x squared minus 12x plus 36 equals 18 minus 3x. I want to move the 18 over. So I had to subtract because it was positive. The only term to the negative 18 on the left side is the 36. So that is the only thing I can subtract the 18 from. So I end up with negative 12x plus 18. Still have the negative 3x on the right side, so it still doesn't equal 0. Then I'm going to add 3x to both sides. Negative 3x plus 3x cancels out. Negative 12x plus 3x is the only terms that I can combine. I get x squared minus 9x plus 18 equals 0. Now, because it equals 0, I can factor it. So I have x squared minus 9x plus 18 equals 0. My a equals 1. There are no greatest common factors, so I can go straight to my big X method. My b is negative 9. My c is 18. And I'm looking for two numbers that multiply to give me 18, but also add or subtract to give me 9. And I can always create a table if I can't figure out my magic numbers. Smallest number that can go into 18 is 1. 1 times 18 is 18. 2 can go into 18, so I want to include it in my table. 2 times what gives me 18? 2 times 9. And I could keep going. 3 times what gives me 18? 3 times 6. And I could continue the table all the way down. But in this table, I am looking for two numbers, or one pair of numbers, that can also add and subtract to give me 9. Well, can 1 and 18 add or subtract to give me 9? No. Can 2 and 9 add or subtract to give me 9? No. Can 3 and 6 add or subtract to give me 9? Yes. So 3 and 6 are going to be my magic numbers. Now, I want to say, okay, I have 3 times 6 to give me positive 18. I also have 3 plus 6 to give me negative 9. Well, this addition does not match up. So I've got to change at least one of them to make it so it equals negative 9. Well, if I make one of them negative, let's say the 3, that doesn't give me negative 9. If I made just the 6 negative, still wouldn't give me negative 9. But if I made both of them negative, that would give me negative 9. So now I'm going to do negative 3 times negative 6. That does give me positive 18. So using those magic numbers, my factored form is x minus 3 times x minus 6, and still equal to 0. So this is our factored form. These are not our solutions. So we have to take each parentheses and set it equal to 0 and solve there. So plus 3 on both sides. X equals 3. Plus 6 on both sides. X equals 6. And those are our two answers for number 7. Alright. For number 8, I do need you to fix one thing. The parent function for radicals is y equals square root of x, not y equals x squared. So in this case, we are determining the transformations. We are creating our two tables, one for the parent function and one for the equation given. And then we're going to graph it, and I did already graph it for us. So first, shift change. So our negative out front always reflects over x-axis. Our 3 is positive and it is greater than 1. So that means we are going to stretch. Our +1 is on the inside. We're going to be disobedient. We're affecting the x's. So we are going to go left 1. And then lastly, we have +2 on the outside is affecting the y's. We're going to be obedient. So we are going up 2. So now you can see, let me do this. You can see here that I went on ahead and chose 5 x values to use in my parent function graph or parent function table. I told you guys to remember these 5 numbers so that it is easier for you to fill out these 2 tables, because these 5 x values give you all of these perfect whole numbers as your y values. There is a reason for my madness. So, with this being said, we need to look through these shift descriptions and determine which one actually affects the x's and which ones do not. So, stretching it. Our stretching, was it on the inside or the outside? It's on the outside, so it's going to affect the y's. R reflects over the x-axis. Was it on the inside with the x or the outside? It's on the outside of the radical, so it doesn't affect the x's. Our up 2 are also on the outside, so that doesn't affect the x's. Lastly, our left 1. Our left 1 did. So we're going to use our left 1 to transform our parent function table to the function that was given. So left 1, if I started with x is, sorry guys, if I started with x is 0 and I wanted to move it left 1, so 0, 0, left 1. What would I have to do to the x value to make it -1? I would have to subtract 1. So I'm going to come in here for all of my x values and subtract 1. So that means my new x values are -2, -1, 0, 3, and 8. Now, for the other transformations to find your y values, you can either put it in a calculator and find all of them, or come into the y value table and do each transformation to each y value. So it reflects over x-axis and stretch. You're going to come in here and multiply by negative, 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 and then multiply by -3. The negative is coming from that reflect over the x-axis, and the 3 is coming from the stretch. We are also having to affect the y's by moving up. So you're also going to come in here and add 2 after you multiply, or after you reflect it over the x-axis and you stretch it. So you can either go in there and mathematically do it, or you can go to your graphing calculator use these x values that I just showed you how to do earlier and find your y values through there. But your y values should be error 2, -1, -4, and -7. Once you get those, that would be your graph for number 8. As always, if you have any questions, please let me know via Remind, comment on this video, or in Google Classroom, or by email.